So empires, yes,
Hmm.
all good empires don't start with making people do something. They erode slowly. There's a control structure. It's an interesting thing. What creates an empire is someone, some group coming out with a really good idea,
Hmm.
and people turn and look at this and think, that's a really good idea. Usually it starts with a belief. So you could take the pyramids, for example. How did they manage to build those? And people will start saying slaves and stuff like this. How do you go to a land of small people, small individuals, a
Hmm.
few of them,
Yeah.
and get a larger amount of people
Hmm.
do stuff for you? You cannot. Think about it. Try it. Anyone would be able to do this today. Mound people together. You'd say money and different things like that. No, 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 no. Because people will always ask, what's in it for me? And with people to put in that much passion into something, what drives it? There's also a reason of what crumbles it. And then there is a behavior that comes from all of this. So if you think that the pyramids were built by slaves, think again. That seems silly. Slaves. No. No, 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 no. We got to go back into the time of the people and the mindsets of the individuals that were inhabiting the planet at that time and go back even further. What was the mindset that inhabited people then?
Hmm.
You see, what do people worry about today? Do you think they're the same worries as what your ancestors had? Most people believe yes. It's actually bollocks. No. Their worry was if I didn't hunt enough,
Hmm.
I couldn't have children.
Yeah.
Well, I could, but they would die. If you did not bring home food.
Hmm. Yeah.
So, very early on, food was the most important thing. Not a mobile phone, not a house, nothing else like that mattered. Food was the most important. Nowadays, we hear it where people are like, always keep a roof over your head. Why? So I can stay in this money trap. Why? So I can make billionaires more richer. Right? You understand? See, this is today's understanding of it. I mean, we would say slavery. Slavery, it always changes. The narrative changes in order to confirm what is happening now, right? But not saying that that does happen now, but just the way things progress that way. No. A group of people came together with ideas,
Yeah.
ideas that would shape the way people lived comfortably.
Yeah.
The pyramids, after all, the Egyptian pyramids, is nothing more than if you look into my eye.
Yeah.
Do you see the triangles that go into my eye?
Yeah.
And you see the corona,
Hmm.
and then you see the dark,
Yeah.
which also looks like a star.
Hmm.
The all-seeing eye.
Hmm.
Look into the eye, and if you look even further into it, you might see a pyramid peak. And if you take out all of those blades that come out of it, of the eye, what have you got? Very interesting structure, a temple, a belief, a worship, something. I don't think they were tombs. Not at all. I think these were significant sacred places. And I believe that the sacredity of the pyramids was symbology for the belief that they all held.
Yeah.
The sun god behavior, sun god, god of the star, the life giver
Hmm.
in these types of ways. So if we take this, for example, and we were to draw lines that come out of the pyramid, and we were also to draw in on the pyramid the things that people call ramps, yes,
Yeah.
that then go out.
Hmm.
And you do this here, here, and at the sides, and you do it on all the corners. What do you have? You have a flower, a lotus leaf, a star. The eye is significant. Your own eye is significant because it surrounds darkness with this pigmentation of this light. It seems to be inverted. But still, the darkness inside, and then there's another layer of even darker material inside your eye. So you sort of have a corona. It's very interesting. And this is what these are, eyes, basically. And you would then understand, where does all that belief come from? Well, how do you build pyramids? Well, this becomes a group of people coming together, which then begin to influence more people. You can see it today. We call it the House of Commons. Why? The House of Common People coming together to do what?
To govern themselves.
To govern themselves? No, to make a better life for everybody that supports the common purpose. That's what the House of Commons is symbology for, what it's meant to be for, is that you have a collected individuals. Now, back in the time, it was different, but still, could you imagine this? So we take the House of Commons. We're just going to do it this way. Now, what happens if every single person on the island begins to feel, what's in it for me?
Yeah.
And we go back in time and we'll say, food.
Shelter. Protection.
How many people would then gather around that and begin to put into that purpose? There's more. This list goes on. You would see that you don't need to make slaves. People will naturally gravitate around that because it's authentic. It's got to be authentic for it to work.
Yeah.
That more and more people begin joining the ranks. Then you have a common purpose, a common agenda. Then you could go in today's world, you could then say space. Space is tricky. It is very tricky, but it's not impossible. You could say space. You could say plants. You could say, today's understanding is a little bit lost. It's more about control and these sort of weird things. And that's now where you start to see the pyramids change the same way, where it started off as a bunch of good ideas and then it moved over to control.
Yeah.
Then people revolted and then walked away from that belief. It's a temple. That was a temple, a place where the people gathered together. We understand it with the House of Commons. We have a harvest festival, which is fallen out of tradition and a lot out of favor. And it is not one really massive event that we should all cherish, but we lost the meaning to it. The harvest festival is all about that we made a good crop, a really good crop, that it should be a day, that it should be a weird thing that we should do as a celebration. Everyone gets one meal, roast meal, whatever it may be, at the end of this. And families are encouraged, it could be a day where you could say that this is where we're going to have, everyone is entitled to this food, fresh, healthy food, and a good pudding afterwards for free on the state because of these reasons. For you to cook it, we'll give you 1 day free energy.
Yeah.
Do you understand that then becomes quite a celebrational, that is like nothing you've ever seen before, right? For 1 day, it's free. This is free. The food is free. We've got enough. Just 1 day. The energy to cook it, prepare it.
Yeah.
Which aims at the end of summer. So this could be utilized of solar power. This would change the minds of individuals as you walk forwards, because that is a massive statement back to the people that we collectively made this happen to allow for a good harvest. You don't need to control that. That doesn't need control. That's, oh, okay then. And the art would be to make this such a widespread thing that this becomes life. Freedom of energy. So what could we look at that as? Free energy. Literally. That would be a hell of a statement, wouldn't it?
Yeah.
That you're here, you put into this, we'll get you this, we'll sort that. Could you imagine that? Because that's where it should be heading to, but no one is putting this in black and white or paper and pen and typo and whatever, binary text. Where should you be heading towards? Free energy, free food. People will be like, whoa, there would be anarchy. Well, no, not really. You think about space. Space is tricky, don't get me wrong, but it's not impossible. When you start reaching something like that, that is energy security then, isn't it? Then you protect these things life tooth and nail. food, life tooth and nail. You have all of this, and the belief doesn't become a religion, it becomes a possibility of what a nation is capable of doing. Coming together for all of these things to work towards one another's better good and everything else. And how many people would give up and become hobby, not work, hobby? What type of an empire could you create? Think about that in a realistic sense, that there wouldn't be this thing of money and who's got the most of it. No, it's who can give back to the people that the people put into the person in order to make that achievement possible, that unlocked a door for everybody. It's got to build towards space. It's got to build towards this. It's got to build towards... And then how many people naturally fall into line? They haven't got to do anything. That's the thing. But if they want to, any and every opportunity is there for them to do it. How many people could get together with that and come together to build something that is a common purpose, which is the House of Commons, a common goal, which is to achieve all of these things? Everyone else would be like, ha ha ha, that's impossible. It only takes one nation, whether small or large, to achieve that. And the people, more people will want to come into that, and as so it begins to expand a new empire. That's the way it works. Why? Because what's in it for me? A bit like the pyramids. Well, what are we going to do? Well, we're thinking about ordering these seeds together, making order. The Egyptians were doing this. They hid a lot of it towards the end. And again, you name me any place that hasn't done that. You know, when they start to lose a battle, they begin torching all of their stuff, right? They begin burning it all, and then you start to lose the, you know. One thing that kills empires is Ice Age. Every single time. Metal becomes brittle. Metal becomes weak. Yeah. Okay, that's one thing that destroys an empire. The one thing that survives through all of that is stone. That is the survivor.
Yeah, it's natural materials, isn't it?
Also, there's a lot of infrared from fire. Lots of infrared from fire, in fact. There's quite a bit. Infrared, you know, you want to think about it as plants. Plants grow really well around fire. And it's interesting because it's almost giving them, it's recycling the energy. So if you're burning logs, for example, you are converting that solid into a gas. Okay, got to be careful with the atmosphere and these sort of things. But again, in this case, it's not so bad. And when you convert that into that solid into a gas, the plants around collect it and then convert that gas back into a solid, which then they put into their trunks, different things like that, right. And they then take that and then put it back into a solid again. It's basically just transferring energy from one. You see it transform, but it always seems to have memory while nature is around, right? So burning a tree near a group of trees, eventually those group of trees, if enclosed, will take that energy and reconvert it back into more carbon fibrous materials again. And once again, begin to hold on to that. Sure, there are some things that it hasn't quite caught up to yet. Our ancestors were doing a lot of weird and wonderful things, and splicing is a very important part of their journeying. They were splicing things a lot more than we care to imagine. They were farming. They all say that there's no traces of any farming. During an ice age, things get wiped. It almost seems, you know, glaciers, everything else. It just destroys an awful lot of stuff that was there. And you think that water erodes. Ice also erodes too, you know. Yeah. It's actually even more greater because of the amount of pressure that it puts. It crushes a lot of things together. And as it slides, it's moving unevenly across the land mass. And some things are more easier dislodged and moved, and some of it is moving one way and another way. And then you've got the erosion of the flooding. And the erosion that happens. So, yeah, you're going to get displacement of nature. That's usually what happens. Trees grow quite fundamentally massive in these environments, but a lot of them get lost. But they would have burnt an awful lot of that. Now, coming out of situations like that, one, they saw how brittle metal got. Two, if they were and had energy, which I wouldn't put it past them, past before the Ice Age, before the Mesolithic, there's a reason why the Mesolithic is one of the biggest periods that you've ever seen. And it's not because metal wasn't there. It clearly was. And if they were digging and tunneling and doing things, there was strange things happening with the hematite and everything else. And they would have not seen this stuff. They would have seen it. They would have found it. They would have known very easily what to do with it. I mean, gee me, they weren't Egyptians pissing about with comets. And there's volcanoes. Again, you can take it out and find ways to take out this lava, cookware over it. You can do a lot of things around these. Very dangerous, but at the same time, for the greater good. They would have been sick and tired of seeing their loved ones die because of starvation or because they couldn't hunt or because they couldn't get this. And farming, they were farming. Perhaps the vegetation was more poisonous. It was safer to let animals eat it and then eat the animals. Much more obvious ones would be berries and stuff like that.
Yeah, they wouldn't be farming in square fields. That would be patch here, patch there, maybe something like that.
You know, all small bushes grow into trees. They put the design in their leaves. It's an interesting process that they're evolving too. And all of these things that we call shrubbery and the smaller, more, if you actually look at it, it's only going to take a little bit of time before that evolves into a whopping great big tree.
You never know. They could have farmed the trees instead of.
So we look at hawthorn, and you can see that as being a giant peach. It's fleshy, or a nectarine. Expand it, and that's what you got. You've got a peach. So that's potentially on its way to becoming quite a fruit of the future. We often look at evolving where humans and animals, but never nature.
Yeah.
We think that it's not really evolved as much as we know about it. It's current knowledge that I've heard people, and whether this is hidden or whatever else, they don't really see it. They just know that elm, birch, hazel come at the turn of this ice age and different things like that. Yeah, what before that? What didn't make the grade? What did? What didn't? So when you come from that, there would have been a lot of need to protect. And again, you don't need a lot of food from nature around fires to feed. It would take you a lot more food to sustain civilizations if they were eating vegetation. You need a lot more of it. Oceans, these would have been free for all. You can find these. People still do this today.
Yeah, fish everywhere in rivers.
And especially under the ice, it would allow them to get a lot more places. Yeah, it's not all big, thick layers of that. There would have been some flow there. And there would have been hot and cold spots. Don't get me wrong. And then you've got that's when the inners of the world really wake you up. Hydrothermal vents near volcanoes. There would have been running and flowing near these areas. You might want to walk towards these. Maybe you don't. Clothing would have been especially important. They had it, but it just wouldn't be what you would expect today. Now, whether they had electricity back before the Mesolithic is high probability. Aztecs and different things like that, it would have been more clockwork based. I'm sure they found ways to make electricity. However, during an ice age, it failed. That's the difference. It failed spectacularly. If we have an ice age, power lines, gone. Transformers, totaled. The poles that hold all of these power cables, internet, mobile phones, gone. It is only going to last for as long. And then we've got to understand, is our atmosphere liable to expand? If it does, it captures all the satellites. They all fall to the ground. We often look at our planet as one solid structure. It isn't. We often look at it like that. But its atmosphere is expanding and contracting. And it's sometimes doing it a bit more extremer than other times. There's a lot of nuances going on. And under these events, certain things happen that may result in expansion of atmosphere. We do this now. When we burn things, we are converting solids into gases. If it wasn't for the collecting going on elsewhere, where it's reconverting that back into a solid, not the same solid, but it's reutilizing this. And plants will eventually will be able to cope with carbon monoxide. That's a no-brainer. If they want to survive, that's where their adaptations are going to need to begin to take root, and they will. The thing is, humans have the ability to help it. That these experiments ought to be done on the air of caution, because if you get something like an ivy that is capable of converting carbon monoxide or different gases like that, it would do it too quickly and it could plague the planet. So doing this stuff where you can do it away in safety, above a volcano perhaps, you know, if it starts going fuck up, in it goes. It only needs to burn and stop the process from spreading anywhere else, or being able to find a way to completely shut it down if it goes wrong. But, you know, in this sort of genetically modified, we call it, that is the next level. But there is natural modification that happens when seeds get crushed in the right way, and a lot of this does happen. And there was a lot of staple foods as well about corns and different things like that, acorn and whatever. If these come about slightly later and they've travelled, people have brought these from other places as well and brought them here. Romans especially, sweet chestnut, conker. Yeah, lots of them actually. They brought a lot of stuff. It was important for them. More than meets the eye. Egyptians did it with things like butternut squashes and melon and... Yeah, they were more after these types of foods. But again, a collection of seeds. That is farming. What about the ones that made those patterns in the rock?
Patterns in the rock?
Yeah, the ones that were up mountains, they couldn't grow food there, but someone somewhere once discovered that when they put these patterns in, which looks like to me, it looks like an ancient quarry, is what it looks like. It looks like some quarry. So they were obviously looking for something. And it doubles up as a, you know, they would have had a lot of enclosed structures as well, especially colder times. So we sort of live in a hot and a cold age. We also live in an atmosphere that expands and contracts, which is irony. So things that kill empires is definitely going to be ice ages, things like this. Why? Because no one has thought ahead. So gas, for example, this becomes very sluggish in these conditions. That's a no-brainer. I think most people know this, that the colder it is, gas just doesn't really want to respond the same way. That is very interesting. Yeah. A very interesting thing indeed. Well, again, another event that could be is tectonic plates. Yeah. If these create a peak in some of the most depths of the ocean, and begin to push that water up, and the water's got nowhere else to go except for around the circumference of the Earth, then that is going to cause a very big problem for land mass. Earth is a water world. By design, it's supposed to be a water world. If you were to calculate all of the water in the isotopes that you have, in order for it to make what seems to be a small amount, it's interesting. If you go to some of these depths where you can't penetrate it, right? It's very interesting. That's why Jupiter fascinates me. Although it's layers and layers of cloud deck, there is a certain ratio inside that that you can't penetrate. It's too thick. You'd almost walk across it. That's interesting, isn't it? There's so much there that you can walk across that. It acts like a very dense liquid, and even we're in a liquid, but we call it a gas, but still we're in a liquid. That's why we can't run so fast. Superhumans would never work here. You know, if they started running through the atmosphere really quickly, you'd see them and then you would just see a cindered spark. Where did they go? They must have time traveled. No, they met resistance to all that invisibleness that you see, what you are perceiving, because the eyes lie. The eyes have been told, do not see that. And the brain has also said, do not see that. And we think that this environment is empty, all in here. We're sitting there looking at space going, is it empty? No, it's not. It's filled with fucking jargon. And your brain and eyes have been told, don't see that. But there's this other part of you which makes up for it, that tells you that it's there. So travel too fast in this emptiness of nothing. And that's why things have a tendency to get very hot. Because it's hitting, these particles are hitting, and this is resulting in heat. And that's an interesting thing. And even in the water, if you go too fast in the water, you're liable to, it's too much hitting you. So Jupiter being the same thing. Oh, that's interesting. And space as well. That is fascinating. That your brain eyes have been told not to see something, and you then begin to perceive like it's not there. Like that's crazy. If humans could be in control of that, that would be like making a door invisible, deleting all of that you couldn't see it. And then on the other hand, if things could travel the speed of light, you also wouldn't see it. It's a very fine frequency we're all tuned into, isn't it? And there's a lot going on that you cannot see, but there's another part of you that says there's something here. A knowing that fills in the gaps for this unknown, unseen, unheard, unsmelt, untasted. It's fascinating, isn't it? But it doesn't mean that because you can't see it, that it doesn't affect you, because it does. Which is then sociology, environments. You might not be able to see carbon monoxide, but it definitely does affect you, right? In a very bad, negative way. It affects a lot of things in that way. So just because you can't see it, that's a
doesn't
misnomer.
mean it's not there.
It doesn't mean that it's not there. And it doesn't mean that it can't see you. And it doesn't mean that it can't interact with you. At this current ratio right now, it's not interacting with you. But move too quickly, it begins to become noticeable to you. Oh, what's that? It's magic. Well, it's not actually. It's this stuff is hitting you. Oh, so that means there is something there. Yes, it's fascinating the way you're programmed to not see it. But it doesn't mean that it's not there. Why? Well, because if it wasn't there, you would drop down dead. Well, you wouldn't. The body wouldn't have grown you with instruments to breathe the gases. You would have, life comes in a very beautiful shapes, forms, and it's wonderful. Mayan calendar, but still. I find that incredibly fascinating. But again, so these changes that happen across the world, let's say Mariana Trench was where I was at, and it peaks. This water has to go somewhere, and landmass disappears. And then luckily there's an ice age, right? Wouldn't you think so? At the right time there would be an ice age. That would be quite an interesting thing, wouldn't it? And again, when you're walking in this environment, you get hot, right? So is it that you're getting hot because you're running and you're exercising and the body needs to cool down, or is it because you're moving faster and lots more bombardment is happening? And this is warming you up, which is quite interesting. So you can walk far. The one thing I noticed when walking from multiple journeys from like Norwich to Wyndham and then Wyndham to Norwich after one another, you get very hot to the point where it's reverse of hypothermia. It's more like, man, I'm paradoxically undressing because of how hot it is. I mean, it's middle of winter and you're steaming in t-shirts. Right? And it's because of the walking, you're exerting a lot of energy. So you also have to be able to eat along the journey as well, which also sustains your heat. So migrate with your animals. I mean, it comes with a leash and off you go. The food stays fresh this way. And they also breed along the way, especially if they become tame. You teach them this and feed them. You would find stuff for them, although they can't themselves, perhaps in the ice, but you can. And if you happen across anything that's frozen, shinay, mate. Make your fire. With what? All of this stuff that we can dig up from here. Anyway, so still, drying process is interesting. You can freeze dry things. It's just fascinating. And again, surrounded by a lot of conifer, this stuff is flammable anyway. Greenery is very much, that stuff burns pretty quickly. And if it is pine, a lot of pine, simply pine resin is your greatest tinder. Most people underestimate how flammable this stuff really is, but get that lit and it becomes quite impossible to put out. And even if it does, you can spread this across parts of pine, which will give you enough to light the pine itself, and even that helps with combustion. However, the needles tend to leak a gas that almost dances the flame out, which is fascinatingly weird, but again, it hasn't developed enough for that. But yeah, so what makes empires come together is people coming up with good ideas. Shall we be able to build this, this, and this? Yes. Shall we grow this, this, and this? Yes. Although a lot of them failed in the Ice Age, the ones that give it a good go anyway, they learnt a lot. They learnt a lot about food. That really enhanced them. They learned a lot about metal. Metal become brittle, very brittle. Some metals become so brittle in cold temperatures. And then how cold did it get? That's another question. In each of these ice ages, what was the peak coldness? If space is minus 350, what happened? Was it a meteorite? Did it blanket in dust?
Yeah.
Was it this? Was it that? Did it hit into a place where there was once a very deep crater, let's say, like a Mariana Trench, and the meteorite fit there and caused some wobbling of the plates, which then pushed a lot of this water up. And as it comes up, it expands, which very quickly would erode a lot of land mass and then sink back down. When a meteorite hits, it's going to do a lot of reverberating, a bit like the moon. They'll say that's because it's hollow. Things don't need to always be hollow in order to transmit vibration. In fact, I think vibration travels better through denser objects than it does through hollow ones. That's interesting, because if you speak in space, you can't hear it, but yet if you push together and create that, the sounds are much likely to go through the floor and into your suit to be able to hear someone, because it loves to reverberate through dense objects, and the Earth is dense. Hit with a meteorite, that probably rung more than a bell. And then what happened to the plates? Did they fluctuate? In this, did it then push the water up and cause it to hit across landmass further than it had ever been before? And with that creates fast erosion. Any farming, anything that was valuable, that was left on the surface at a moment's notice. We've got technologies these days, but even then, how quick is it to get a signal around the world? Before that, you would already be feeling it. Probably be too panicked to even bother looking at your phone. Then has it brought down a lot of masts, towers, anything else like that, which delay the signal even further. So that's TV transmissions as well. That would be you're on your own. Plus, with this water coming in very quickly, I mean, what much, if let's say that we go through farming with Britain at the moment, let's say July, August, getting close to the end, and this event happens, meteorite hits in somewhere, it fills a lot of the trench, don't get me wrong, a lot of carnage goes on, but it starts reverberating the plates, which acts as jostling and even more disturbances, and then water begins to filling across the land. Then it washes out. And then it reverberates again and it pushes out and it comes back in, and then they slap into each other and cause this. How much of the land and displacement to a lot of trees, nature and anything else, what can withstand that? Not a lot. Then how much of debris is going to be brought up? Sand is going to be covering the area. I mean, we see this in layers. Every meter is 1,000 years, is it? In the layers, and then we get to sediment.
How long? Yeah.
Well, is that sediment because that was under the ocean and it settled down, or was there an event like this begin to happen? And there, it takes a fluke for it to hit in these areas, but there are many things that can cause it. It doesn't just need to be a meteorite. It can be an earthquake. It can be an object orbiting too close to the Earth. This is going to create a lot of. This can move the plates.
Yeah.
And by doing so, where do those plates move? What fault lines are affected? And then that water that seems to be very deep and pressurized, which makes it into an isotope, 1, 2, 3, go down to a certain depth, and you can't penetrate this with the best technology that you've got. It's nigh on impenetrable. And they'll say, yes, this is because of the pressure and everything else. But that pressure, if I was to take a cup of it, a cup of that water at that level, and bring it up to the surface in some weird imaginary way that I could do it, and then open it, it would be like 1 billion liters of water would come from a cup that big, at that density, at that pressure that it would need to sustain at that liquid level. And then as soon as I opened it, it released it, and like Pandora's box, it'd be like magic, wouldn't it?
Yeah.
It's a bit like trying to take Jupiter's at its pressure deep down. You're near the metallic core, let's say, if you could even get there, and you cup it, and you're like, okay, I got it, and then you bring it back to the Earth. That cup would, how much of an atmosphere would that create on the Earth? Just from one cup, you could swell your atmosphere. It's interesting. There are several ways to combat Jupiter. One, fill it with oxygen. If you had loads of orbiting bodies around Jupiter, it's made of hydrogen, yes?
Yeah.
It's that big. So very quickly you could calculate into this, what would Jupiter need to make it shrink? Well, if I had loads of, rather than the moons orbiting Jupiter, I mean, I just think out the box a little bit here, I'm going off topic. I fill Jupiter with a lot of plants, let's say. Let's say there was some magic that I could get a load of carbon, CO2, let's say, somewhere to feed the plants to convert that gas, and I had loads left over into the plants to convert it into oxygen and then pump that into Jupiter. Jupiter being so big and so pressurized that that oxygen would bind with the hydrogen under that pressure, and it should then begin to cause water, which should begin to shrink its atmosphere. And then what comes? Well, you could make another Earth in this process. It's a weird thing, isn't it? The pressure would begin to... Now, whether there's any rock in there, which there's got to be, but what does that look like? Is it liquid? Is it, you know, if it's next to a metallic core? Then there's got to be some, perhaps a liquid rock around it too, a liquid crystal. Yeah. Now, how would that look? That would be a very interesting thing indeed. But again, if I begin to collapse the atmosphere down, it gets smaller. Will it shut down its heat source? Perhaps. Will it begin to shrink the magnetic field too? Or there's a high chance that it being that big, full of hydrogen, and if there is oxygen there, then it means that there must be a water layer there too, or a vapor layer. But if I start adding more CO2, convert it into O2, oxygen, let's just say, and I knock in the oxygen with the hydrogen, or even if I knock carbon in there and just miss the plant process anyway, but still, let's make it look good. Because you will want to eat that food anyway, which is not energy lost. It's a bit more well spent. And you begin to collapse it. How small is Jupiter? How small do you want it?
Yeah, you want.
These are fascinating things. Another way to be able to pull out large amounts of... you see, you want to condense gases into ice. That's one thing I've noticed with the universe. It just screams it at you. So let's say if I got a liquid and I managed to fill it up at the depths of the ocean, if I was to freeze that, that would be the only way I could get it to the surface without it exploding, is if I freeze it. Well, it's going to expand a lot out of its ratio, but even still, if I could freeze it at that depth and then bring it up quickly, then you would watch that thing melt, and it'd be like a never-ending ice cube. The more it melts, the more of this torrent of water you've got, and just... But where that water, and depends on what that water is made of and how pure it is and untouched by pollution, that each time I brought that up and this layer of water went back into the ocean, melted slowly, the dirtier water would condense into that. It has to, a bit like the energy if I were to cut down a tree and put a load of trees in a biome somewhere and burnt that and converted that into that, then the trees then begin to take that energy back. Now, if I take that energy, freeze it, bring it up, and then allow it to melt, which then it would begin unpacking, but in a much more slowed down way that you could see it, that water that would then overdose the ocean again, back into the ocean, would push the next layer down into that depth, because it meant it made gap. Yeah, I guess as soon as you pull it up, something's got to replace that. So that's an interesting thing. And then it makes me wonder, how much could I compress water to the point where it turns into isotopes? And keep compressing it. And, you know, I could make something so good by doing this, that if let's say if we could compress all of the ocean water down into a fucking sugar cube. And I want to weigh it. Against what? Go get me a teaspoon of that black hole. Which one weighs more? 100 tons of water compressed and iced, or 100 tons worth of that black matter over there called black hole? Well, they both weigh the same. I'm going to go stand with you. You seem like a clever fellow. But you compress things enough, and they're going to get heavier. A bit like the star, compressing lots of this gas. Let's say we call it hydrogen, and at the moment it can compress it into a massive chunk of frickin' iron. Nice, very nice. There are more, by the way, but still, that's a hell of a compression, isn't it? And a lot of things are doing this right now as we speak, aren't they? Called stars, yeah? Which then makes me wonder about thermal radiation and shit like that, that you've got to be a certain level away from something. And if the heat comes from the star, how is it coming? That's another question. Because surrounded on a planet full of stars in the sky at night, And if you add up all of the points of light in the sky, minus the planets, but still, let's just add up all of the stars. That's a hell of a torch. It almost exceeds the star, the sun. But its heat's not reaching us because it's further away. Thermal radiation, if you understand it. But there again, what is absorbing all of that heat? Space? Where does it go? Come on, space, what do you want with it? It means that space should be pretty hot if the heat is... So sunlight, we take it for granted, don't we?
Yeah, we do.
And is sunlight being the heat of it, not the light? But that heat ratio is because, what, we have a mercury? It aggravates it? Which then begins to aggravate that and push off this heat layer. This heated layer, and again, high-charged energy particles as well. That's heat too. That's bits bombarding the planet now. Is that causing heat? So if something is orbiting very close to the star, because remember, the star is going to conserve energy. It doesn't want to give it out all of its heat. No, you know, go get your own. I don't have any of mine. And then all these particles get aggravated, and I suppose so, and a magnetic belt on there as well, twists and buckles, and well, what causes those magnetic belts? Well, it's the star. Seems like the star was built to be dumb as fuck and throw away all of its energy then. No, something else is aggravating that, which is creating which is twisting the belts, which is the planets orbiting, which, you know, neutrinos must be spectacular. And all of that heat and energy gets lost at the heliopause, and what, space? In space behind the planet, space is what, 350 degrees below zero. That's interesting. So what is the current temperature of space then? Because that's still got generating some level of...
So is that the coldest there can be? Or?
No, because interstellar space and black holes, my word, they must be pretty damn cold. They said hell was hot. I don't think so. I think it's cold, don't you think?
Yeah. Hot is what is shining bright, isn't it?
Hot creates growth, creates life, creates it. You need both, actually, light and dark.
Yeah, you do.
You also need that too. You know, we're the forces of three, aren't we? Light being what, white or the star, and then we've got darkness being black, ink black. It almost appears that way. And then with a bit in the middle, the ratio in the middle of these two contrasts that sees color. So we're the color ratio, third eye versus the eye versus color. Interesting, really, isn't it? Someone else gets me talking about this as well, which is the reason why I got this. It's old, but still, it will do the job for the understanding of this experiment. At this ratio, if I were to fill this up any more, it would explode. Let's say it's a 1% ratio. This is fascinating, by the way. You might like this. So we at Earth's current level, yes? And these levels I'm going to do down here is like under the ocean, yes? And let's draw the atmosphere, but we should give that a different colour. Want to go with blue? Well, if you like. Yeah, sort of. We're going to give it a very egg shape. There we are. So this then becomes space. But I'm going to call it low. So low Earth orbit would be about here, and then we've got the depths here, and then we've got even more so here in these margins, which then you start to reach, and then there's interstellar space as well, which is a fascinating thing. Space is loose material of black hole. All the way around you, just because you can't see it, can't perceive it. It really wants to pull things apart, especially the astronauts that got out and look like Michelin. Really, it's having a good go at you, although it just doesn't have the might as what a black hole has, but it's got a good enough amount of might. The reverse of that is true with planets. Pressure. The only reason why this doesn't explode, and you can put gases inside here, is because the atmosphere of the Earth is pressing against it in multiple directions. So the weight of the atmosphere allows you to fill this with pressure. And as long as that pressure doesn't exceed the push dynamics of the atmosphere pushing against it, that's your limit. You reach your limit. So let's say this is 1% at this level from exo, which is explode but short. If we now were to go under the ocean with this, strange thing would happen to this, especially the stuff inside. It would begin to crush, especially if we went down to the depths. it would crush down so much. Why? Because now the atmosphere, being the ocean, would be so concentrated on this that it would be able to crush it. And there's not enough pressure now on the inside to hold up the structure. So if I wanted to know how this metal would stand out, I suck out all the gases completely, and what would happen on the atmosphere? In the atmosphere, if I sucked out all the gases, what would happen to this can?
It would stretch.
No, if I sucked out the gases.
Sucked out from inside.
Yeah, in this environment now that we're in, and I took out all of the gases, every single one.
Then it crumbles
It
inward.
crumbles. Why does it crumble?
Because there's nothing there.
Yeah, because there's nothing inside it, which we often believe that it crumbles because you sucked all the air out. No, you put it at neutral state, which meant that the atmosphere is the upper pressure, which was able to crush it. Not because you sucked the gas out. No, because naturally there shouldn't be any gas in it.
Because there's no pressure when you suck everything.
There's no pressure on the inside pushing against the outside.
Yeah. So outside will be stronger.
The outside is stronger, therefore it crushes. Not because you suck the air out. No, I suppose it could stay that way, but if you pierced a hole in it, it might try and expand itself. I very much doubt it. But it would try and take in what was lost. Anyway, now the reverse of that fact. If we take this down to the ocean, and the ocean is now pushing, which is atmosphere, condensed atmosphere, is now crushing this. So at that depth, let's say we go to this depth here. At this level, I can only fit, let's say, 1 can's worth, and 1 more % over, it would explode. Too much pressure inside there, which then pushes against the atmosphere, which you think is quite a lot, but in a small volume.
Yeah.
We go under the ocean now, and let's say we've gone quite a way down to the point where this is starting to crush.
Yeah.
Is it possible that I can get now 2 times the gas cylinders inside here? That was the first one that I could fill in on land.
Yeah.
Then we go down deeper, and now I can do 2 times the amount. Then I go deeper into the isotopes until this wants to crush down again, and then I can make 3, now 4, now 5, now 6 versions of that.
Yeah.
Until I keep going. Where's the limit? There is no limit. The limit is whatever you want to settle at. What's the most pressurized area? Now we start taking the sun. That's got to really push down on this can. And you're going to need a hell of a force to push this back out. It even proves this with submarines. So, Navy! You know what I'm on about. You could put a piece of string from either side, and it begins to crush the hole. If you go down too deep, it ruptures, and then you need to create more pressure, which would be ballast water, to pump more air out. But again, that's limited to what you can withstand with inside the hull, and therefore it would squish you like peas, and then you overpressurize it on the inside. That's an interesting thing. So there is a limit to the depth that you can go down to.
Yeah.
This can also works that way, but if let's just assume, but again, it wouldn't work unless I had Christmas tree effect. So I would have to put down a can into the ocean like this in order to fill it, because the lower down I go, the less gases I'm going to be able to have to pump into another canister. So I would need to hit from the surface here, and this one we always pump in the gas into here, which doesn't work very well if you're a submarine, because you'd have to always have a snorkel out, and the deeper that you went, it would have to keep on, because then it's going to have to push gas from this one into this one, into this one, into this one, to keep this one maximum, because at that depth, it wanted to crush down to halfway. Now I've got 2 times the can in there, 1.5 can in this one, 4 cans in this one, only just to be able to fill the can at the bottom, which is this one. And then I've got 1 trillion of cables all the way down, which you can do it. Just why would you want to do it? Now, here's the fascinating thing. Rockets. A lot of information is useless without keys. You need keys. You can be given a whole picture, everything, and see it all, just like you do with your brain and your eyes. Yeah, you see it all, right? Don't you see it? You see everything, but without the keys. How did you find out that energy, or whatever you want to call it, the blackness is full? How did you figure that out?
You don't do.
And if you could see that blackness correctly, would you be able to see stars? Question.
Yeah, that's a question.
And then it poses a brand new question on top of those 2 questions, if they would be questions even to begin with.
Yeah.
How the fuck are you seeing it? By looking through something that the brain doesn't realize. And therefore, that's when people say, it's not there. But it is there. Just because your brain has been told not to see it, and your eyes have been told, don't register that. I love this obedience. The brains are so obedient. The whole body structure and everything about it is so obedient. It doesn't question nothing.
Yeah.
except for the vessel inside all of this is doing the questioning. But the brain, the materials, you don't question it, it just does. And you can't see it.
Yeah.
You need a key. You need a key to be able to see this stuff. And when you get the key, so camera would be a key. Infrared, well, you can see infrared. That's a kind of a bullshit statement. But infrared on a remote control that you can't see blinking, you cannot see it. Yeah, the camera can. The camera has the key. The key to see that. Now that's interesting. What's more fascinating, right? Infrared is quite a lot everywhere, yes?
Yeah.
Now, if I press that infrared here near the camera, do you know what's amazing to me?
Oh.
You can't see anything behind it. So in a moment you can see all of this.
Yeah.
If I get the infrared, I've played a lot with this as a kid. When you take the infrared beam and hit it into the camera at the right angle, all of this disappears. You can't see past it. Isn't that amazing?
Yeah,
But yet if I had the key to turn off that infrared,
Yeah.
and if I just put it on and be like, what can you see? I can't see anything. What's behind the infrared? Nothing. It's empty. And then I turn it off and then you're like, what? I could put loads of naughty things up on the wall, couldn't I? Loads of graffiti and, mum sucks or whatever else it might be. It's just really... And you wouldn't see it because the infrared is stopping you from seeing it. The reverse to be true. It's almost turned off a lot of things and then you'll be able to see further. Why? Because you're meant to go that way. You don't have to, but still. That's fascinating, right? So this, in this instant, the lower down you go, you can add more energy to this. Now, what a fascinating thing for me is, what happens if you freeze it at that level? I'm assuming you could. And now, at the bottom of the ocean, at the deepest you can go on the planet, let's say, with all that pressure of the water and atmosphere and everything else heavy down on it, you've now added so much into this can. It's no longer got one version of the gas in. Let's say it's got a trillion, just argumentative. Let's say it's got a trillion versions of gas in there, and each time you put one in and the deeper you go, it compresses it. And it keeps compressing, Yeah. Eventually it would give up, but still, let's just say, assuming that it's got a trillion in it, what happens if I lift that up? All of a sudden, back to surface level.
Yeah.
It would explode. Yes?
Yeah.
That's fascinating, isn't it? Don't you find that interesting? Here's the kicker. How much fuel would you need to be able to lift yourself from that depth? Well, about this much pressure worth, wouldn't you?
Yeah.
And it would need to expel a lot of that energy before it reached certain areas, yes?
Yeah.
That's what gives you lift. But I could get to the surface with it, though. The only condition is, the condition that I would be met with is, A, I'd have to strengthen the arse out of this, and if I did, it would be too heavy. And therefore it might not create lift, so it would defeat the object.
Yeah.
So it would be better if I could time it to get a lot of that energy expelled out of that canister. When it hit a certain point, it would already have wanted, or at this depth, it would already have wanted to have released 4 times that amount. At this depth, 8 times the amount, 12, 1,000, until it reaches, and then eventually it would reach you up to the surface, which is an interesting thing, isn't it? Isn't that fascinating? And then in space, it really wants to pull this apart, but yet not objects that are frozen. Struggles with the frozen ones. Yeah, you look at a comet. Take a look at a comet. Here comes the key.
Yeah.
And when you look at a comet, it's frozen on there, right?
Yeah.
When it gets close to the sun begins to convert that frost material into a liquid, which then separates as a gas, and it gives you propulsion.
Yeah.
Well, it gives the asteroid, or comet, I should say, propulsion to move around.
It gives it that tail.
Yeah, it does.
doesn't
It gives it a very nice tail,
Yeah.
and in some instances, it can cause it to rotate, move, and do all sorts of weird and wonderful stuff. The strongest thing that we've got here is carbon wraps. Carbon is a very new thing, where you wrap things in carbon, give it special structures. Yeah, it's lightweight as well, not kind of. In these sort of circumstances, it's a fascinating thing. But if you were to freeze it and make it frozen, and it only had access to depressurization at the part where it was melting, you can go a lot further, and therefore it would, for stars, when making pressure rockets, you always got to think about that. The certain things in space, you've got the opposite happening. You've got space wanting to pull apart the outside of this. There is no pressure holding on to the outside of your propulsion system. That's the thing. Another device which is it's coming, but in the future I will give that converts energy as it travels, and the more heavier the payload, it demands more in real time. So you don't ever actually put a fuel in it. It's interesting. It creates the fuel and it does it in such a fast ratio. So imagine a rocket that doesn't have fuel. It does have fuel, but it doesn't need fuel tanks. That's the thing.
Yeah.
It does it from the environment itself, which you would understand it as being the shit that you're all living in, yeah? And this, the heavier the payload, the more faster it absorbs the fuel process that it requires and mixes it in an instant to push it out the other end, which then gives you the lift, utilizing nothing more than just the environment itself. The problem is, it only works on pressurized environments, which gets you past a lot of things, but it's got to be able to be built from a structure that can withstand crushing depths. So the deeper that it goes into something, then it must be able to withstand that in order for the integrity of this rocket. It's weird. It's more like a platform. Aladdin's carpet. It's fascinating. It is very interesting. It's I don't know. It's just it's very good. Could you imagine that? It does have a downside to it, though. If overutilized, so it potentially could fly around the planet constantly and never need to stop. And it would do that quite happily, going and going. However, it would eventually run out because it would convert the fuel source. It would it would make global warming look like a drop in a very, very small ocean, a large ocean. It'd be like a drop in Jupiter. It's an interesting sort of process here. Anyway, so it would work on the Earth. This is Earth-based only, unless you could find an Oort cloud. No, a nebula that was made up of the same makeup of what Earth is, and then it would happily go through these. Sending one of these out using current rocket technology to push this out and hit it into a nebula, it would fly into a nebula. And it would be able to map the nebula slowly but surely, but it would transform what the nebula was if made from the same ingredients that the Earth is. If it was wrapped around the world, it would look like Aladdin's carpet. It's the only way I can explain it. And yeah, it could whiz around the planet over and over again. But if you had lots of these, the problem is with it, it's super lightweight, so you don't really need that much. It all depends on your payload. And never will you need fuel tanks, and never will you need to lift fuel up into, I don't know, let's say into fucking where airplanes fly and whatnot, the atmosphere. You don't need the fuel tanks. And after all, it's the fuel that is the most heaviest thing. Also, these work great on trains. Fucking brilliant on trains. It will revolutionize the way transportation is. There's a few more, but yeah, all in good time, my pretties. Anyway, still, and it essentially pushes the train. That's basically what it does. And you need two, one at the front, one at the back. But it never needs fuel. It doesn't need an engine. It is the engine. It is very small. And all it needs to do is move. The heavier it becomes, it knows this in weight versus how much thrust is needed to push this. And the more better the wheels are, which the wheels would have to be designed a little bit different. The train track would have to be designed dual and upside down in an essence, so that it could hook under and on at the same time and grip the track on a rail so that it fits into the niche. Holding to the ground is the best part of this process. The heavier it becomes, there would be no limit on the weight. So this would be able to move things. Think about that. You could move fucking towers, skyscrapers with it. The heavier the object becomes, this knows, based on this, to calculate how much, and therefore how much needs to be grabbed in an instant to push it out, to give it that. It's fucking brilliant. It only works on the Earth. That's the problem with it. Maybe there are a few other places that it could work, but you need nature, a lot of nature, because it works alongside nature in a very beautiful way. But anyway, still, I don't want to get lost in that. That's later on. That's very much later on. But this rocket technology is fascinating, which is probably why Germany were using alloy, or fucking around with alloy. They were trying to make strength from materials that could withstand this type of close. There's a certain structure, but again, it becomes heavy. That's the problem. It becomes very heavy, and then you need more fuel to be able to lift. That's the problem with current rocket technology. But don't get me wrong, with this type of technology in the wrong hands, people, it has to be given to everybody equally. Do you know why?
Why?
Because war. That's if everybody all had it, then they were less likely to all use it because we've all got the same arsenal, right?
Yeah.
So,
Yeah.
and that's not what war's about. War isn't about giving everybody the same technology at once. No, it's about you having a really great technology
Advantage.
and hiding this shit.
Yeah.
That's then domination. That then triggers them to maybe use some other stuff. So you have to give it equally. It has to be shared equally. And then it's a checkmate situation. Yes, you do have the best technology ever, and it's very impressive to the people. However, it's best probably, because you're going to be in that situation. And if you know anything about martial arts and stuff, then you'll know that one day someone goes and has a fight with one another, and this person wins. Yeah. On one particular day, this person wins, this person loses. Technically, they didn't lose or win. They just trained. It's the luck of the draw. And then the next day, same people fight. This person wins. And this person loses. And then twins understand this very well. I do. Well, we were fighting all the time. But yet no one ever got an advantage over everyone because one day one day this. And it wasn't in days, it was in hours, depending on the game. Depending on what type of battle you were into. Not really. No one's really winning, and even in certain fighting situations. But usually the mind tells you, that's the bit that separates a lot of people from other people, is that, do you remember that time I fucked you up? That was once. One time. The problem is, when that one person fought you, this person being the wiser one, maybe, or both senseless as shit, that this person fought in a way that revealed information to this person that now can counter it. And then if they learn to change their tactics, do you see then this has the advantage now of winning? And not just winning once, but if they then built an arsenal of different versions of what they could do each time, this person would never, that's the only way you can really truly win, but it's kind of dirty in a way, because you're constantly changing your stance over and over again, and then you can win. But if the other person learns that too, then it becomes the same progress again. That's fascinating. So one person wins, and then it's left, and then the input of the crowd around says, that person whooped your ass, that person whooped your ass. But if they then fought again, it's like, hold on a second, which it doesn't usually happen because it's not by natural design. Most people are told that that person put that person in their place, and then that was it. Yeah, and this is kind of weird. War is a very strange sort of same thing as well. It's weird, isn't it? It's very fucking weird. But yeah, one day one might be able to get the better of the other, and the other might be, and that's why they call it timing, right? Yeah, anyway, but still, and then if the other ones did something later on, they then know this behavior, and then you would have to shift it again, and then shift it again, and then shift again, and then shift again. That's called being an adapter. That's adaptive. That's a beautiful, beautiful way to be. Being able to shift that whole behavior, and it really confuses people because they go in with that same. People find formulas and stick to it. Have you noticed that in this world? People will find a way that works, and they stick to it, and they stay with it like it's holy grail because. Well, it made me win before. That then becomes stagnation. That's very stagnant. I see this a lot, and I look at that and think, right, could I counter that in a billion different ways? And if the answer be yes, then good. Then it means you're not stagnating. And that's a fresh mind to be able to think that way. It's a fucking weird thing, but by and large, most people believe that it's one strategy, it worked, I'm going to stick with it. I don't know. Never mind rocking the boat. What happens if you capsize it? Could you make this boat go underwater and fly the same way? Could I turn it into a submarine? You're going to sit on that. Can I make it fly through the air? There's a sort of difference. But anyway, with the gas and different things like that, compressing, if you freeze it, man, I would be able to unpack a whole atmosphere there. And if you can keep it in the cold, which space is very cold anyway, and it keeps things quite frozen until something gets close enough to a star, then the comet tail starts because it begins to melt the ice that's on it. And that's why you got some asteroids that have liquids on them, and some do not, because they've burnt out their energy, if you like. And that comet tail is interesting because it means that you can't actively predict where it's going to go, because it's got vents which alter its trajectory quite a lot, actually, until that is no longer got the tail, and then it's a bit more predictable. It's very predictable. The star can predict that. So when you've got a lot of gas compressed into a cylinder like this, so even on Jupiter, you'll be like, no, we're going to need loads of fucking fuel in here in order to be able to lift off. Yeah, but at the same time, you would need to utilize that in order to get off it.
Mm-hmm.
Isn't that weird? And then if you're in the depth of the star, things just naturally begin. By the time it's full, you know it's time to go, if you could withstand the pressure. I mean, that's a fascinating thing, isn't it? That you can get more into a volume than you were first expected, because it's isotopes then, isn't it? Once you've fully compressed this gas into a can, let's say, and then you add more pressure on the outside, you then start converting it into gas isotope 1 surface level. Mm-hmm. Then at the depth with 2 times the amount in there, 2 isotope, 2, 3, 4, 100. Mm-hmm. And then you've got different isotopes. Now, what happens if you freeze those isotopes? And then you could haul-ass it up into space, can't you? And then can you keep it protected on the dark side, naturally refrigerated, which then keeps things in their sort of order or orbit? Stops them going haywire. Because when they start to go haywire, they might get propulsion, which then can fling that into a planet. Isn't that fascinating? And yeah. So the debris that have all expended, interesting. The stuff that comes in with the comet tail, that must have come from somewhere else. Or prehistoric, something got smashed, whether it was a moon here, whether it was a planet here in the beginning and it got put into the Oort cloud too far away. Interesting. Or it came in from interstellar and it travelled over. Well, it's going to be harbouring something in that ice. It's fascinating stuff, isn't it? Don't you think so? Mm-hmm. And then one more, Europa. Mm-hmm. Could you imagine if you actually could heat that up?
Yeah.
How big is its atmosphere?
It would puff, wouldn't it?
It would. So do you reckon it's got a lot of iron inside there? The red ridge lines. There's either a bacteria or something along these lines, or it's iron. And therefore it's got hydrothermal vents on it, which is interesting, fascinating. And then is there enough there to allow a layer for the gases to hit up on the underside of the ice, freeze, and fall back down, which would then give you a purification process? Maybe, maybe not. Give or take. But there must be some way of purifying that water to make it a bit more fresher for anything to actually live that is better life form. That's an interesting thing to think about. But that stuff there definitely looks like iron. And iron is in blood, right? Iron is very brittle, by the way. It's very brittle, susceptible to cold. Most things are. Is it hydrogen or nitrogen? Nitrogen. Hydrogen. Cold stuff, gas.
Nitrogen.
I always confuse these up. Anyway, so nitrogen, yes? Mm-hmm. That's interesting, the way things freeze and they become very brittle, yeah? That is fascinating. It's like... almost gives you an insight into how black holes operate. Make things very cold, extremely cold. And then what can withstand the coldness? Yeah, hell is cold. Not hot. Cold. Cold, because things become brittle, fragment, fall apart. Nature, well, it doesn't really like it very much. You can already see this. Life forms don't like it either. That's another thing. It's fascinating. Very fascinating. So yeah, well, what kills empires? Ice ages. Yep. And this probably creates inside people's minds, we don't like metal. And that's probably why the Mesolithic has outlasted this very small metal age. Because if they had knowledge that's been lost, but still perhaps known, or maybe not known, that metal didn't fare very well. You learn lessons very quickly, and then you promise that you're going to go over to something and stick with it. And bone antlers, hair, compressed hair. Hair for tying things is fascinating. That's very strong. It doesn't give a shit about the cold or not. And also bone. Bones are very fascinating things. Incredibly sharp, by the way. So an antler from a deer can be carved into what appears to be a drill, and you get a little handle on it, and it's incredibly strong. Ivory, do they still do ivory trade these days?
I don't think these days they do the old ivory, but new ivory is not supposed to be traded.
So is concrete supposed to be labeled as being very strong then?
I don't think concrete is very strong. It crumbles.
Yeah, I understand that it crumbles.
Yeah.
I do get this, but when people compare your thigh bone
Yeah.
as being equivalent to a slab of concrete,
They do.
when to break it, it's supposed to be stronger than concrete.
Oh,
When people compare the thigh,
because it has better structure, doesn't it?
I understand
Both
this. Yes, I get this, but the fact is, why do people compare it to concrete? What is that analogy or comparison to? I wonder. Meaning that this stuff is supposed to be incredibly strong. Therefore, meaning that the bone is really strong. Then you understand that bone drill pieces for tapping trees. Then there are bone cups. So how did people make types of pottery, if you like, back in the day for drinking and cooking? I think it was bone. Don't you think?
Yeah. It's easily available if you have big animals, especially. You have big bones.
Well, if you have a very big bone
Yeah.
and are able to hit this into the ground and fill it with a liquid, I'm pretty sure it will hold it,
Yeah.
and then make a fire around it. This becomes your prehistoric, and how to carve things would have been bone. Bone, especially deer antlers, are incredibly sharp. And if you put these on a disc, make a compass with it, and spin the bone antlers very fast, very compact, look like teeth sticking out. You got to get them all down at the right size to do so. How much do I want to say? All of it. And you put these together, and you make these rotate really fast, you can cut down trees, big trees, very quickly. And it doesn't hold up very well. You could probably cut a few trees. The blade itself will survive, but the mechanism that you use to rotate it will not. And there's two mechanisms. One is a pole in the ground attached to bark. And if two people get on it, as well as it's attached to the bark, and you swivel on it back and forth, it creates one of the bark layers to expand open whilst the other one contracts, meaning it's leaning this way, and then you go the other way and the other one expands and contracts. And if you put these into place into pieces of wood, these create a full circle mechanism. Then if you take that and you tie it, and you can use lots of things that are very strong string fibers and keep rolling these around, you can then make a large cog power a small cog that is then connected to an object. It's very big and bulky, but again, they had the time to do it. You can bring down massive trees with this, huge trees. And what's more, it chips it. It chips into trees. You can carve it very easily. So metal that would be considered to be very flexible, you couldn't heat it very well. Not to them. They wouldn't be able to heat that very well. But bone is incredible. And also bone holds heat. So there would have been another, but yeah, on this mechanism, if you get back and forth onto it and pull it, and you have another one, you can create rotation, very fast rotation, and you're using bone. And yeah, these bone stakes, and it depends on how many you've got, and that's why there's probably not much left. You will find this, I'm sure. You must have found it. You can do an awful lot with this stuff. Bone is strong, incredibly strong. So is different types of plaiting, and these fibers when they really come together. And if you keep them damp, which outside it is damp, inside it's dry, this creates some strength, like impressive strength. So is hair. Hair is capable. I've seen some dude pull a train and an aeroplane with a beard and hair. And I think I've seen some ladies pull a train, but I don't remember if it was ladies. I'm not sure. It didn't really matter. But you understand how that's hair, and it's not plaited, and it's incredibly strong, and depending on how long you grow it. So farming, cultivating, and doing things like that, it's possible. Get an animal to pull a bone a tusk, and you can plow very easily. And it depends on what they were growing. So bone is a fascinating thing, isn't it? And considering most people used to use bone, so yeah, sitting there with a flint tool, fuck that. I'd use a piece of bone. Have you seen what that stuff can do? That's incredible, and it's not. Yeah, it's not really bothered about temperature very much. It is and it isn't, but metal would have been seen to be too brittle. Yeah. So, if you've ever got there with bone, you can also shape stone with bone more easily than you can most metal objects.
Yeah, there must have been plenty of those animals.
And you can make a handle on it.
Yeah.
If you want to carve it, you use the weak stuff to carve it, and then it becomes a strong tool. So in an arsenal, I've seen a lot of people using flint, but I often look at that and think, too brittle. It gets the job done, don't get me wrong, but what were they going for? They wanted the antlers. They wanted the bone structure, and you've seen wild oryx. Have you seen how big their shin bones are? Have you seen the size of them?
No, not the size of
It's
them.
3 times the size of a bull, and nastier. Can you imagine what you could do with the bones of that?
And they have also horns.
That's
they,
also,
these animals.
this is the boss.
Yeah,
It's known as the boss.
Yeah,
It's capable of impact.
Yeah.
So if I wanted to use something to hammer something, it would be the boss.
Yeah, there are so many different deers, kind of, and bulls and animals like that, and all of them have antlers or horns, or so. I'm sure that our ancestors used those.
Well, I wouldn't be making a flint axe. I would be using a boss of an animal carved off of a bone and removing all the bits I didn't need, and I could split wood with this and tree trunks very easily with this, just bone. It all depends on what you could plan to do, but the antlers are very strong, unless they're heated. They can be scorched or broken. Don't get me wrong, but what they put up is incredible. And again, the animals were much bigger back then, and they had a lot more tusks.
And unless you put those antlers somewhere in the fire, you don't scorch them. How would you do that?
And we haven't found a lot of dinosaur bones, and they are 1 or 2 pieces over here, and the rest is plaster, right? Yeah, I think our ancestors were using these.
Yeah.
If you come across that, you know,
bones
could you imagine the skull or the cranium version of
over
a dinosaur? You would make that into a pot, turn it upside down, and cook a fire underneath it. You can boil water, and honestly, if I believe that they didn't have hot water or means to do it, our ancestors were not stupid. It was all about survival and recyclable and what purpose things had. And all things had a purpose. I mean, even if the eyes were glue, bones were this, that was this, hair, tails, but a horse were on the menu. That was a sustainable food.
Yeah.
Most people don't own horses and are sentimental as fuck when it comes to horses. That, you know, if anyone even mentions the word eat them, but they were on the diet. All this stuff was, and that's a big animal too.
Yeah.
So yeah, bone would have been my go-to. Yeah, I use bone. And it's slow rotting. Have you not noticed catacombs? I mean, and some of those ones in the river that were waterlogged, Jesus, man, they are pretty dense. And to think about some of those, I wonder if now, I'm honestly starting to think if that was an oryx bone, which might go and just have a look to see if it's either a horse, could be a human. Nah, never that big. I'm taking a piss. Yeah, I'm taking a piss.
Yeah.
But even still, pretty big bone.
Yeah, there were many, weren't there? Yeah.
Yeah, I would utilize this stuff. And if that is, it depends on how long it's been dead for. I don't get all finicky about things like this. I go pick it up, smell it. Yeah, it smells like water. Yeah, and test it. It's incredibly dense, especially when wet. Could I find ways to fill those cavities up? Probably could. And what could you use that for? Hammering in ivory nails.
Yeah.
Do you think? The Bone Age, Wood Age, Glass Age. So yeah, I can get it very hot. That's a good thing. And You could do a lot with it. It'd make a pretty terrible cauldron, but it would work nonetheless. And it's very clean, isn't it? You can clean it really easy. So, yeah, that would have been my go-to. And especially if you were living in chalky areas and clayey areas, I can also dig very deep with these, hammer things in, all sorts. So yeah, bone. Bone would be the place to go to, I think. Yeah. Especially if you were hunter-gatherer. You would make use of every single part of the animal.
Yeah.
So, yeah. Yep. I think I'm going to leave this one here. There is loads more I want to talk about, but okay, I'm going to leave it. Yeah, this has been good talk. Good talk. Yeah. So, and doesn't metal rot away quicker than bone?
Metal.
Yeah. If exposed to the elements, doesn't it?
It corrodes.
It corrodes pretty
very
quickly, and it rusts.
Yeah.
I mean, it's a dirty blade at the end of the day, isn't it? Most people sit there making all their knives very nice and make sure they're very clean and stainless.
But you have to constantly.
Dirty blades are probably the ones that they used to favour to bring someone down because it would create that tetanus or perhaps something along that. Not very pure though. But flint is easy to shape with bone as well, which then gets you more bone.
I think that our ancestors used all of it.
Of course.
Simply what they had available where they were at the moment. If it was a piece of metal, they would use it. If they had antlers, they would use those. Why would they bother? If they had something else, piece of flint or something else, they would use that.
But it would have been what was easy available.
Yeah.
I mean, how much digging would you need to do without a purpose?
Yeah, exactly.
You wouldn't really want to do that.
Yeah, exactly. If it was available, I'm saying really available, not like going somewhere and digging and making very hard work to get something to use it.
Yeah.
Because that's...
And then after all of that effort, it doesn't last very long. And they were very much in the mindset of things needed to last. I mean, they'd gone from carving trees to stone and stuck with it for the longest time ever. And it's probably because it was tried and tested. I think spacecrafts made of stone would be more fascinating. They would be able to withstand an awful lot of the shite that goes on in space. I mean...
I think that metal was mainly jewelry and it was bronze before any iron or anything like that, because they were able to make that. And these days you still find all those nice spirals that they would put through their ears or on their arms and everywhere, or
also
they
copper
chain
as well, wasn't it?
Copper,
too?
yeah, stuff like that. Metal that was easily available. Just heated, they found it somewhere. There was something, could have been silver, could have been anything. And they made themselves pretty.
Yeah.
Yeah.
It was easy to do so.
Yeah,
it
but
mimicked certain things.
yeah.
I could probably get down with that. But again, green skin, fucking hell, Osiris must have been buried in the stuff.
Well,
I think that's pigmentation.
Yeah,
actually.
they wouldn't use it if they found out that it was doing that, probably. For
it was
very
quite
long.
toxic though, some of this stuff, wasn't
exactly.
it? So, but again, you can become hardy to this sort of stuff until the body then needs it. We were also living in pine, a lot of pine. There's your vitamin C. If there's a lot of pine around the world, vitamin C should be increased in the environment because it's leaching out. You can't help but get this stuff, and therefore you live within it. And pine needle tea was quite the thing for a lot of reasons. So there you are, pine needle tea rich in vitamin C, and then there's those berries as well, isn't there? There again, wide and travelled. If pine dominated the world, vitamin C was everywhere. You couldn't help but breathe that shit in. It was so advanced. And also birch drinking that. I often wonder how the hell did you manage to puncture into a tree that way?
Or maple.
Or maple.
Yum.
Bone.
Yeah.
You can carve the bone.
Yeah.
You can medieval type drill. And it's not a drill bit that you think with all the spirals and everything. No. The flat blade.
Yeah.
With
Cracked
the sharp
bone,
point,
yeah.
and then you begin to, the drill bit that it's the flat one. Do you know the one I'm on about? The one with the sort of point, and then it's got the blades either side.
Yeah, I know which one you mean.
Which looks like Cece on the side. Hello.
And smile.
That's just what we do. Anyway, but still, along this sort of mechanism that rotates, and if you put a good handle on it,
yeah, that wouldn't be hard.
and you could carve that.
Yeah.
And then it's about pressure, and again, wood is not going to stand a chance to that. I honestly believe that. So, especially skin or fleshy material. Yeah, and I'd be hesitant to make. I was wondering about where the feather stick came from when carving. It's one thing I've tried to do, and I've failed and succeeded in different aspects. Is trying to make a bow and arrow, technically the arrow, but without feathers, by carving the wood. Getting but it's tedious. But again, if I had a lot of time, I take a very big chunky piece of wood and carve the other side down to it's nice and thin, which represents what we see as an arrow. Yeah. And then begin to make feathers from the feather stick, and begin to carve crude feathers that are made from wood, as opposed to feathers and sticking it on, which again gets me so far, but it's how do you get it through the bow without it snagging on the sides, and that's by making it gradually start off thin and get chunky, and it pushes the arrow away. You'd have to use 2 pieces of wood. The current bow and arrows are 1 piece and it rests beside it. Yeah. This one is 2 pieces of wood with a gap in the middle that allows the arrow to travel unscathed without it touching any of the wood. It relies on your hand, so it's 2 pieces of wood, not the traditional arrows that I see people make. It's 1 piece, and you hold it here, and the arrow will situate here, and the elastication comes from the 2 either side, and then runs through the middle of the 2 bits of wood. So it's essentially like this, with a gap that's big enough for your arrow to go through the middle without you needing to rest it onto the side of the piece of wood, which then always fucks your aim, by the way. You have to compensate that you're going to hit it and it's going to push the arrow in a direction. So you have to off aim when using bow and arrow. If you aim straight at it, it's not going to hit it because it's going to move the arrow in a way because it's going to push on the flight, the feather, and it's going to alter its trajectory, which you always notice. And then there's a lot of flex. You don't want that. If you're going to make a bow and arrow, you got to make it with jewel, with a nice gap in the middle for the arrow to pass through unscathed. You'll get your fingers, but it's not going to pierce your finger, but it will right off your finger. Then your finger becomes the aim point. And with that being good, because you're standing up and you pull a bow and arrow, when it catches the wooden flight, the last one, it pushes the arrow in a downward trajectory. Because that's one thing I've noticed, that they all aim these big, bulky, they don't want to aim very well. Your feet get in the way and everything else. It's too much hard work. You might as well pull it and allow it to naturally fly off your finger and then go down towards the direction. And what's more, your hand becomes the aiming point as opposed to the piece of wood, which then means you have to off aim. So yeah, that's how I would do it. And it makes for longevity on the bow as well. And it's less likely to break because you're sharing the strain. If bows break, they're dangerous. If you use 2 pieces of wood, one side of the piece of wood will probably break, but because it's fastened to the other piece, this acts as a safety mechanism that stops it from slinging at you. So it will break and hold there, then your bow is broken. And you can put this together in a number of ways, so you don't need screws or anything else like that. Bone works really well. Even pieces of wood staked on either side and hit these together and then bum the ends. That's one way to do it. And then use birch tar to hold these ends in place, which again, it gives a real good bow and it stops it from being broken on numerous amounts of times. And it really does become your tool, but not this whole 1 strand. No. 2, because I want to hit the target. That's the difference. And I probably don't want feathers. As much as they're good, they're a hell of a pain in the ass to put on. It's much more easier to make a feather stick, not for lighting fires with. Although, if it got broke, don't get me wrong, it's fucking great tinder. But at the end of the day, I want to keep things very simple. And and then I can use jewel elastic for that. Dual purpose, and I can pull it more. I can get more force behind it, and even if I'm close range, It's going in. That's the thing, and it's going to go through. And I could also make an arrow then. I could get intricate and make it from bone. These people were carving bone after all. Look at what they were making with it. That's sad because wood does not survive. Although they did say that they found some wooden bows that were like at the start of the Mesolithic. But I question that because in the pyramids, all of the wood inside there, in dry, good conditions, it's all fucking disintegrated.
It would have to be in bog only.
Even still, bogs still break down materials.
Don't know.
Oh, I don't know. Maybe in a bog. Perhaps it must have preserved it somehow. And
it preserved several people in it, but who knows? Who knows?
I don't know if that's perfect, to be honest. You'd find it more so in ice, wouldn't you? Trapped in ice layer.
Yeah.
Would be more likely.
Yeah. Mm-hmm.
I don't know. Someone did say that wooden arrows don't survive. You know,
They don't.
Unless it's like a super paramount conditions. So, but again, it argues the question that they were into birch tar and tanning and thermal plastics and different things like that, which none made of bone. Seriously, man, these things break. You'd use the bone to bring down the fucking animal to get more bone, wouldn't you? Well, it's too precious. All right. We'll save that for later then. But Oryx, that'll take a lot more than a fucking bow and arrow to bring that fucking thing down, isn't it? Like 16 hits? Well, I'm always getting dinner. I'm always going to be getting dinner. That's going to be it. So, nothing's off the menu. Think about that. It's like already like so many different varieties of food. Wow. And the animals were more back then, weren't they? More plentiful. So that's a very interesting sort of ways where we come from. And then when you think about that, what was the need that made you build pyramids? And then it's worship, temple, belief in what? Better life for everybody.
Yeah.
Then people might want to start moving away from this because this isn't what it was. This is not what it was said to be. And then they were like, no, we're set in stone. Our mindset stone hardened and look at what we did for you, you bastards. But we all did it. No, we did it for you without. And then the argument happened, blah. And you can see how that then falls out. And then there's a big argument. And then perhaps they were killed and put in there. And then it looks like a tomb. Very morbid, but although I don't wish it upon anybody, but still, it's almost like coming across, when I think that I can use this as an example. What happens if the same situation panned out here today? Not saying that it would. I would never want to do. There's too many protections in place to stop it anyway. But still, if members of the Houses of Parliament were put into the Houses of Parliament, and rather than being on the benches, they were laid out as a funeral place, and people then left behind and different things, would be eerily similar. The people thousands of years then fast forward on from that would then come across the Houses of Parliament and be like, it must have been a church. Mm-hmm. It must have been a tomb, or it must have been this.
People worship those people on the walls.
And these paintings must have been drawings, and but was it?
And
the information was lost because people forgot about that time because of control or different things like that, and then perhaps there was the wives' tale that got started. There's some shades of grey in the truth. No, it wasn't. It was people come together for common good. To build it. But then what made people all come together? They must be slaves to money, slaves to this, slaves to... Well, no, it didn't start that way. But you could see how very quickly that you could take this on, that it would be slavery or whatever else, but it's not. It's just the way things happened and transpired. There was a common good, a belief that there would be abundance for all, that everybody could live and receive this goodness in order to be able to put more goodness back out. You're always going to need structures for that, and a belief. The belief is this. And, okay, it's come a long way from religion or star. The star, the sun god comes grows crops. They must have been understanding that light grows, opens flower at a certain time when it's much more hotter here, moving to hotter lands, doing this, finding that. None of them like to be cold, shelter and different things. Perhaps they like to be out under the stars. Everybody still shares this today. Open. If you could live openly without the need for houses, which houses keep possessions safe, don't they? Technically, lock, security, whatever it may be. But mainly, you get away from the elements. Although that's a very bizarre thing to do, really. But still, anyway, it's very good for your skin. We talk about natural. Natural rain on the skin is it's got to be good, not with the pollution, but back then. Rich in vitamin C as well, and different trees, and either or. They probably never had dry skin. Do you reckon they did? It's kind of like bathing, isn't it? Yeah, you ever been up close to an animal and you give them a good whiff? They don't actually stink, do they?
No.
They smell like outside. I mean, it's like, whoa. I've been fucking showering for months and I still can't smell like this, you know? I fucking I'll slightly move away from the shower and it's like, was there any point? Damn you sweat glands, come on now. Well, you know, that's just but I think that's a build-up of all the stuff that we eat, the not so good stuff inside the food that we're eating, and rather than it passing through the body, which is harmful, it sweats it out, finds another way to push it out. That's where I think the smell comes from, and a lot of the time when, you know, weird. They're not exactly showering, and it's like, and you're using spit? It's a fascinating thing. Interesting, but very strange. And how much their body temperatures are elevated. And the downside is when they get one, they don't suffer with many colds, fevers and stuff. But when they do get one, it's life-threatening. So there's a difference. There's a transition in that. So perhaps that comes from shelter, being a bit more protected in that way. Interesting though, isn't it? It's fascinating. I love all of that. But still, tenacious. I did want to do something else, but you know what? I'm going to leave it for another day. So yeah, let's leave this here. But yeah, still, common good, common way of reaching something, authentic. More people should rally around that. Why? Not because of the building. No, it's because of the people. Because of the people that come with this good way, a different way, a better way. But what's in it for me? I ain't going to do shit for you. Well, I'll feed you. Hunter-gatherer says that's a good idea. Do you mean to tell me that I would never lose my... Yeah. All right, what have we got to do? See, here's the thing. If we take these things here that we like eating and we put them in the ground and shit, this will grow. And we don't like that shit over there, but they eat it and we eat them. Get a little bit of this, a little bit of that. What have you got? Harvest Festival? That's too futuristic. Just shave it down a little bit. We've got food. Yes, that's better. That's good. Wonderful. If we all come together, we can make some stone pots. Stone pots, you say? I'm going to chuck them on a fire. They're like fucking brew this stuff. Making soup. Oh, that's very good. Oh, that's so good. You know, you were cooking this way and there's more than enough to go around. Why? Because you've mixed it with all the things. We know what's poisonous and we know what's not. Oh, yeah, but these are good. But we'll need those. Why? Because someone else ate those before and they died. Okay, right, well, we'll remove those. And you? Well, we found all of these to be edible. And each family had a different knowledge of where. And if you travel more, then you've got even more knowledge, which didn't mean the knowledge of what was poisonous. No. But the small amounts of what their families had figured out was safe to eat. Then these ones figured out something else that was completely different to them. That was safe to eat. They weren't worried about what wasn't safe. They were worried about what was safe. Okay, can you know this very well? Yes, go and get that. We grow it here. And then if you give this, well, I'll share some of this with you. Okay, and then it's whoosh, whoosh, whoosh. Before you know it, boom, people start exploding. Why? Because growth, no more death. What if they just lost? Famine. What if they then also lost? Well, when their food ran out, they had some food. And what's more, it was safe to eat. They could eat it. You could eat it. They could. And this began to support because they grew enough of the numbers. And then food began to become this thing that was always available. What did it mean? You could have kids. What else did it mean? The kids were not dying from starvation. Malnutrition just seemed to drop off. People felt strong, energized. Then they go and build temples, working out things that it must be from this, it must be from that, better with the water. These ones didn't like water. And then before you know it, look at that. That's what's in it for you. That's when people come together for a common theme that works for everybody. And there you have it. Your first Houses of Parliament or Commons, the Houses of Commons, common people come together and then begin to expand this, which you would call light. But also the darkness too, don't get me wrong, because the foods that were poisonous were also worth knowing. Because, you know, what about if I eat? No, look, poison, this, see? And you've got light and darkness mixed into one, and what have you got? A shade of grey. What's in the shade of grey? A nice niche for families of all varying backgrounds to begin to. And now, where they had more time, what could they do? Create. And what did this creation lead to? Monuments. What did monuments lead to? Knowledge, building, writing, tools, scribble, making sense. Fire. One in the group knew how to make fire, and then before you know it, everybody knew how to make fire. Now learning, holding on wisdom. And then they could also travel out on full bellies, full of energy, of good food, healthy. Health is good for their stamina and their ability to move stuff like this that we look at and go, I don't know about that, mate. Yeah, because probably a lot of the food is shit, 0 calories, most empty of fucking crap anyway. It's filled with a lot of chemical. Your body's just not designed for it. So of course, yes, it's going to hamper your energy. You're eating all the wrong things, perhaps. This has a knock-on effect. And if water isn't good, and this isn't good, and it's already done, we'll just leave. That is when it becomes not great. Not very good. It can then begin to deplete your energy, and it makes you feel shite. And then things are forced, and authenticity always wins. Always. And it leads to great development very fast. So, yeah, that's when a new way comes. But an old one does, usually it takes an event to trigger it. Ice Age, a lot of things fail. It's just the way it is. If it's from meteorite and different things like that, well, where does the atmosphere go? Do we have anything to suck in atmosphere very quickly? Probably not. This would be something that you would probably want to build. You'd do it on a spacecraft. You know what? You could convert. This is interesting. This is a very interesting thing. It might not be possible to get everybody to space. That's something, yes? Yeah. At the moment. But could you not carve the Earth into something so fucking beautiful? Well, you can't now because it's all fucking full of shit. It's dirty. It's dirtied it up. But if it was clean and pure enough and working really well, you can still do it. Don't get me wrong. There are enough people working together can create quite a beautiful haven. But to make an Earth into a spacecraft, being able to aggravate the core in some way, it would be weird to think of it now. But my question is, what if other civilizations went in different ways? Not here on the Earth, but elsewhere. Life. I believe in abundance of life. That's just something that I do believe in. And what if they carved their planet into something beautiful, excelled all the goodness from it, dropped off what wasn't great, perhaps didn't get rid of it, but perhaps we're going to remove you on the moon. Get some more objects closer by. And begin to aggravate the course by stretching and squeezing, which then created an internal sun, a star, or so to speak. It was capable of growing things from that light and heat and that energy. It's assuming that they had plants. And also created a heat that was stabilized. They also were in control of too much gas, not enough. Water was dealt with in a very fundamental way, and there was much for all things. But removed what was poisonous, but it can go over there. Maybe they were like, fuck it, burn it all. I don't know, who knows, right? Maybe there was 2 versions of this. The ones that didn't, it doesn't mean that these are better or those. But again, that wisdom that come here to learn that, and if you were to meet with your different struggles and your goodness, a bit like the hunter-gatherers when they come together, right? With their very small pieces of knowledge, that then when they combined it all together, look at what you do. This is what built this now. You're thinking in the past. You're living in the past. No shit, Sherlock. Full circle. And, these individuals that lived in the past, and these ones that did it over here, and these ones that did it here, that little bit of knowledge, which will seem little, their little bit of knowledge, and their collective of knowledge, a bit like the hunter-gatherers that had to come together and settle their differences. Why? Common enemy. What was it? Death. Kids not having children, that was a fucking luxury that you could even have kids. Never mind that you could find a woman or a man, find a woman, find a man, being able to sustain yourself and food. That's if the planet was in abundance. But going through critical changes like that, may it really test you. And life forms that are over here on a planet, over here on a planet, over here on a planet, and they all come together with, again, what could you do with that shared knowledge? All of that wisdom. The little bits of them of what you can eat and what you can't eat, you try it. Well, okay, we won't be eating those. All the shit that you said that you can't eat, we can eat it. Would you like to try this fungus? We can't eat it, but I'm assuming that because we can't eat this, but the stuff that you eat. And then could you imagine that? All this stuff that was not worth anything to you actually could go on to feed their generation. And then it become a gift that you could exchange for their bad stuff that they didn't. And it fed you, and yours that didn't feed you and poisoned was a delicacy for them. I mean, that is fucked up, wouldn't it? That would make you question whether there was something guiding you. Or it pose another question, if you weren't religious in any way, shape, or form. You would look at nature and think, what the fuck do you know? You'd be bringing fucking plants into interrogation rooms. Speak! How do you know this shit? And then it would then make you think even further, wouldn't it? If this to be true, and to me it's already happened, the mind doesn't tell the difference, but still. What did the people know back then that was sacred with trees and plants, and even the toxic ones, just have this sort of sacredness? Wouldn't it open Pandora's box of thinking and make you think, there must be something in this shit? Because their poison is your food, and your poison is their food. That's the sort of fucking icebreaker right there, isn't it? Whatever useless information did you have? Oh, fuck me, this is dynamite. This is a diamond. And you? Well, we got all this shit. We didn't really... And just by them accumulating this, it helps you understand something even more so. And then that would then pose another question, that nothing is truly wasted. Oh, our hunter-gatherers did something like this. And they would be saying the same thing, and now you're hunting and gathering again, but now in a universe. Now resources to feed the very small, fragile things called life that you have that support you, and you support them. That's fucked up. Most people look at it as inferior, superior, don't you? You think that everything supports you, but actually you are also supporting it. You've come a long way since then, but still, you are still supporting it. You're meant to be. I mean, why not? Why would you not? Oh, fuck it, we'll eat all this fucking mechanical shit. Well, I don't know if that's a good idea. Yeah. What about all these chemicals? See, tastes good. 50 generations later, and then you find out just how not good that was. Man, you mean to tell me that the times now, but they're looking from the future, back then, they were drinking these E numbers and doing this, this, and this? God, they were fucking dumb. And then we were looking back going, oh, those people are drinking all that arsenic, thinking it medicine. God, they were dumb fuckers. I'm glad we're not dumb anymore.
Yeah, always different.
I wonder when that trail ends, when it stops, and then the ones at the end are like, all of those dumb motherfuckers back then.
Probably,
what they're missing.
Probably never.
No, it does eventually. It peters out, but you know, the one thing that kills that is being aware of it quickly and rectifying it. That's what it's all about. That's all it takes, and that's a weird thing, isn't it? Just that's all it takes is everyone just to snap into it. Or you say the higher ends of it, either A, a new system, or B, a current system but updated system that actually utilizes power in the right way to go after this and stop it. That's all it takes. That is it. And this ends. And then that's all it takes. Isn't that a strange thing? There are lots of ways that this can form. Automatically it's going this way, and people are hesitant, no more prone to abuse these sort of systems, and it's a weird thing. It's a very weird thing. Like that will never come full circle. You know, because they might see someone, or their kids might see someone in that cesspit that they fall in love with, generally fall in love with and want to be with, and then all of a sudden the bloodline has now got all of those things that you were just like, fuck them. I mean, that's kind of a weird thing, but still, it is what it is, and stuff like that. But yeah, life forms coming together that way, sharing that, and the stuff that appeared to be useless actually had a purpose. That's a weird thing, isn't it? Almost like something is pushing you in a... Well, it's optional, but it sort of merges you, and it's an icebreaker, isn't it? How you get around all of that, and then what are the benefits from that? Well, sure, they could fucking blow each other up, and it's all done. Maybe one wins, maybe not. Maybe they both annihilate each other. But the thing is, what happens if they actually came together and started to grow and flourish? how much more could they expand? How much more could they know to protect themselves further from anything else that was like that? And what would they learn about all of those difficulties that they could teach the others that were separate how to merge together? You know, it's safety in numbers, and then you begin hunter-gatherers. They're like, oh, we're no longer hunter-gatherers. That's bullshit, you are. Dude, have you seen the way you fight over resources? That is hunting and gathering. It's just changed now. And then in space, hunting and gathering what? Carbon is quite a good prize. Genetic modifying and understanding that. Extreme splicing and finding a very close to natural way to find that. Maybe it can also add in monoxide, which would be a benefit to Earthlings, would it not? All life on the planet, if you found something that was able of absorbing all of that monoxide, how good would that be? You don't think that would be great? That if you found some sort of nature that was capable of absorbing that monoxide and being able to convert it into useful things? That would be good for life, wouldn't it, as a whole? There are a few more that would probably be really good. Volcanoes. All of that shite popping out of there. I mean, that would be interesting. And growing a tremendous, there's another thing that our ancestors did that also is very relevant for today, is the birch trees. Have you seen the amount of birch trees that they have clearly planted these? Now, if you could get a birch tree in its spring moment, don't tell me that it's not possible, because I believe that it is. In its spring moment, how much purified water could you get if you just tapped trees that produced you that water? And still lived a very good life. Yeah. That is fascinating to me. That water out there is like nothing I've ever tasted before. It is so good. I like it. It really gets in those spit glands, and you feel it like, I don't know. It almost seems like when you swallow it down, you can taste it a bit like the reverse of an antibiotic. You can taste it coming out of your saliva glands in your mouth. Have you ever had that? You take an antibiotic, and a few hours after 3/4 of an hour, you then begin, when you salivate, you can taste the antibiotic in your spit. Do you? Oh, I got a weird sense of smell and an incredible taste that comes along with it. And I can taste antibiotic. So every time I salivate, I taste antibiotic. Even though I haven't let it touch my mouth, it's like swallowed it as quickly as I can in that water, right? But
it comes through.
It still comes through, and it's almost like a very strange sensation, to be honest. There, and then the taste becomes quite something. Like getting sick of this taste now. It's like it sort of promotes itself across your body and your taste buds and everything else. You cannot taste anything else. You can, but this one becomes center stage. Scientists said that you can only taste it for so long. Want to fucking bet? I don't have a breaking gene then. It just keeps going. The body's like, what should we do? Should we just keep making the gene? Yeah, let this fucker keep sniffing this. Alright, you get what I mean? I'll keep tasting this. I'm sure it's supposed to drop off after an hour or so. And the body's like, that's other people, but you, my friend, fluky from the rest. You smell that? Yes, I fucking do. It's almost like I'm up to it. Sniffing it. Might as fucking well be. Anyway, sorry about that, but yeah, so birch trees, they're incredible. And then what does that look like for health of humans going forwards? Does cancer disappear? That's a fascinating thing. Does colds go away? Does flu never rise up again? Are we more resilient to certain things? Does Alzheimer's fall down? Does it do something? It's got to have a knock-on effect. And what is it? And considering the amount of nutrients that's in it, and then helping birch, which wouldn't be a bad thing, to be able to, one, grow like this, but also to be able to produce that more than just a few weeks of a year, which you can do. And then if that took dirty, polluted water, not 100% fully polluted, let's not overdo it, but stuff that humans shouldn't really be drinking, but this can take it in a way that is able to filter it. After all, it's been around a lot longer than we have, and give us the goodness. Well, this would be money well spent, wouldn't you think?
Yeah, that would be.
Imagine that coming through your tap. Literally, your tap. Because it can run away, that's the thing. And if you calculate how big some of these trees are and what the amount of liquids they can give without dying, that's incredible. And I'm a great believer that it's not going to destroy a tree. No, the tree is going to go, watch this. You want to show me defying life? Wow. It's going to get bigger and it's going to be able to produce that. A bit like bees. They produce extra honey and let it pour out the nest to feed the bear. So the bear is less likely to go into or humans actually, are less likely to go in and destroy the nest. And they will happily do this. And then they get really good at it until eventually you can they will constantly make this, live a life that's perfect and untouched. The only thing that is, you're catching the honey that falls off. And because this saves their nest, it's in their best interests to overproduce this and therefore to give it to you. And they happily will give it to you if it means that it leaves their nest in complete, not being destroyed. So they don't have to rebuild it, because that is far more easier to overflow that than it is to rebuild that. And, they don't lose their numbers and their kids are protected. In their eyes, it's going to be their children. Kind of weird. But still, that is what it is. They're larvae and whatever else. So, and their queen's safe. So, and then they are safe. And the tree, the same thing. I believe things get stronger, not weaker. They get strength is found. And I think that they defy logic. Some of these things just go on and on and on and expand in order to cater for this loss. But I think it's how you introduce it. And if it becomes expecting, it will expect it, because you got to understand, nature calculates. This is the thing. I find this fascinating with nature. It calculates, a bit like ladybirds calculate weather, but so do trees. So if they've been tapped from a young age, and gently it's getting more and more, they should be able to calculate that. As then, what do I need to do this season in order to, 1, add into this, and 2, add into myself at the level that I need it to. So if you go and bleed it all dry, sure, it's going to die. But introduce it slowly and increase bit by bit. It should calculate that for next season. Maybe if I produce this much and maybe this much. And if it wakes up, it takes a little bit of time for them to wake up. That's the thing. My dehumidifier was filled with all sorts of weird shit. Remember that, and I think it took the lives of a lot of my plants. So never mind that. A lot of it survived, but some of it not so great when it was close to that. And it also might have taken my bird's life as well. That's interesting, isn't it? That's what led me to it, was her. It doesn't matter, but still. And the other's still happy and he's still going. But so this long-term calculation here is interesting. So bringing plants in and introducing it over and over and over and over. They should then begin to, so underground farms or tree, in-house forests would be great, especially if you could pick the right ones that you wanted. Birch, along with some pine. They always seem to grow well with pine. Have you noticed that? Really, really well. And it alters the flavour of the birch sap, if you want to call it that. And you can also make thermoplastic with this stuff, which would be great for helping foundations, I think, in the country using birch tar. Don't you think? That would go near the foundations and different things like that. And it could really help and allow the bricks not to get soaked and act like a wick on the bricks at the bottom there. I wonder how long it would last. Again, this is why we need places. The council should build these. County council, come on. Little places where people can go and experiment with foundations and weird and wonderful stuff. No one's going to live in it, but it's going to be tested and put through its fucking challenges. If you've got a piece of boggy land, build a house there with this type of technology around the outside. Experiment with it. And after all, it's very natural. Okay, it's extracted in a very strange way, thermoplastic, but it does break down, I have noticed. It takes a little bit longer, but it's very natural product. It breaks down. Now, that's one thing I've noticed with plants. Have you noticed when it rains, they don't actually absorb the water on the trunk? They're like waterproof. I was trying to do this when I was trying to fix one against fungus. This is what the fungus is relying on, isn't it? This is very fascinating. They tap into that. Anyway, it's very strange. Could you imagine that on the outside of your house?
Okay.
It's going to allow the liquids out, but not let them come in. That's what we want to make as a barrier after all. And the centre of houses should have a column in it. Like this is a centre wall. If that had a pipe around from the loft all the way down to the under of the house, because there's a gap under the house, and it was a tube like the toilet pipe, yes, the down pipe of a toilet pipe in the middle of a house, and at the top has a fan, as opposed to at the bottom. Because again, trying to change that in the middle of the floor is going to be fucking impossible. But the idea of it is to pull the air in from under the house, from outside the house. And if those air bricks outside the house were to shut down every 20 minutes, open, closed, but the fan in the middle of the house is always going to be functioning and pushing it up through the loft and out. What this would do, when those close, it will then pull the air down from the loft into the cavity under the house and up and out, which the bricks going against the wall. This is rack here, but again, still those bricks get very damp. It will bring air from the loft, which is usually dry because it's hotter, and it will bring it down through the cavity, under the house, up and out above the loft, let's say, in this process. And then it's going to stop by opening the vents for the air bricks. And then fresh air is going to come in, pump up and out, which again should act as a drying process for the foundations. Again, how long will a house last under those integrity in that way? I think for a very long time, because it's going to be drying all of this out. And mold is going to struggle in that environment, I'm pretty sure of it. I just wonder what could happen then. And then you don't need the fans on the inside. You do as well, but they don't need to run all the time. This one needs to run all the time, pulling all of that air in. Moves the air, doesn't it? Yeah. That's the only thing, is stagnant air is never good. If stagnant water is bad and it's toxic and it goes very bad, and water is compressed air, then what does stagnant air do?
The same.
It's got to do the same, right? It's got to get bad and it's got to get nasty, and it's going to allow things to breed. So algae bloom and fungus does grow around stagnant water as well, I've noticed. And the life around it, the trees, very bad. What happens to the air? Must be exactly the same. It's less. This is compressed. If that happens to compressed atmosphere, fuck knows what's happening to the stuff that ain't. And this might be a way for benefiting health as well. It's circulating the air so it goes through the house. And what type of a solar panel would you need to sit on the top of the roof for that? Not a very big one. Just to run that motor all the time. If the sun's up, it's up. At night, probably don't want to be sucking that in. Why? It's usually going to be colder. Could be damper air. And if it's winter, does it switch over this way? If the vent's closed there, it's got to bring in air from up as opposed to ground level. I'm sure the air higher up is going to be a lot more drier than the ground at lower levels. So when those vents close, it brings it down from the cavity from the loft. So it comes in there. And it's got to move that volume of dry, hot, usually muggy air. And the bottom of the house is usually damp. Why? Because its foundation, it's in the ground, it's subject to it. On a hot day, bringing up that hot air from the loft down underneath your house, fuck me, is going to be great. And going up through the center and pushing it out the top, be like the new chimneys of the day. I'm pretty sure damp is going to struggle, whichever side of the wall it's coming from. And no, tenants do not make damp. That's bollocks. That's myth. Wives' tale. I know this for a fact, because all those empty houses, do you see how fucking condensated they are? It seems the opposite is true in houses, doesn't it?
Yeah.
It's like, what the hell? Why is that so damp? Must have a leak. It's got to have something in it, right? Why is it so condensated? It's empty. It's been empty for the longest time, and all these other buildings are empty in there. I don't know. It seems to me the people that live in houses actually are more beneficial to the houses. Have you seen the way the abandoned buildings go? Oh, man, so damp, right?
Damp, cold.
Well, see, because you're not ventilating. It's got no fucking windows in it. Well, it does have windows, but, there's a lot of cracks in it. That must be pulling in more air than I've ever known. That's better than an airy houses that they used to build in the war. Yeah, that would be interesting. And then if you were to then cover the rocks on the outside or all the way down to the slab with pine resin, not the resin, no, birch tar. It's natural. It's not going to cause much of a problem, is it? Only if it burns. But name me a substance that doesn't burn and is not toxic. Just one thing, please. Water. You're a funny fucker, Frank. Water burning. Can you burn water?
Yeah.
My mum's a terrible cook. She could burn water. Burnt rice. I did one of the simplest things. The ingredients are simple. Water, rice. I mean, how did you manage to burn this shit? Anyway, never mind. Might as well fucking boil that dry. Anyway, so Stuff grows in wetlands. Anyway, yeah, so that's a joke. Alright, let's leave this one here and let's wind down. It's been fun. I've enjoyed myself. Yeah. Cheerios.